So the next program will be the insertion. So we'll be using two techniques. The first one is the traditional approach, and then the second is the Pythonic way. Okay? So I'll be having a list item like this, say 10, 20, 30, 40, and then you have 50. Right? And then you'll be having the indexes as 0, 1, 2, 3, 4. Let us understand the algorithm first. So it's a very wise idea to be thinking the algorithm first. Algorithm is nothing but the logical sequence of steps in order to carry out a specified operation. So before you indulge in any programming tasks, first things first, it's so important to get the algorithm right. Otherwise, during the programming itself, if you go on thinking of the algorithm, it's not that a good idea. So the algorithm for the logic behind this program of insertion is you'll be first finding the index or the position where that particular value has to be inserted. For example, if I want to insert a value of 35, okay? If I want to insert a value of 35 in the list, and then just to make the matter even clearer, it's very important that the insertion is with regard to a sorted list, okay? Sorted list. So if the list is sorted, either in ascending or descending, then the element to be inserted, should be inserted at the appropriate position based on its value. Say if the value of 35 is to be inserted, the first part of your program is finding the appropriate position of 35. So you will have the first function, let's say find position, which will return us the appropriate position of 35, which in this case will be 3. This 35 has to come in between 30 and 40. So this 35 as a value appropriate position is 3. This should be here. But so once we get the appropriate position of this, you cannot go on with the insertion straight away. Otherwise 40 will be replaced by 35 and then you will lose this value. So the next step, once you are done with the finding appropriate position, we then need to have another function which will insert a new slot, so that this value will be pushed on to this and 40 will be pushed to this, and this is how you leave the room for the new element. So basically this program has two different parts. The first one is finding the position and then shifting and then finally inserting the new element that is to be inserted. So let's move on with the program. I'll be writing the definition first. Say you have the def. The name of the function will be find position. And then you will have two arguments. The first one is list, and then ELE is the element that is to be inserted. In this case, it will be 35. So there are few cases. The first case is if the new element is less than or equal to the first element. It's a possibility. Let's say if the value of element is 5, which is less than the first element. If it's less than the first element, then it's understandably the appropriate position of the new element will be 0. Okay? But before this, let's have some variables like u. I need these variables for the program. Len of list minus 1, and then I'll be using this counter to traverse the list. Okay, counter will be initially 0, and then the initial value of position will be minus 1. Not sure whether I'll be able to have the program fit. Okay, and then to start off, let's say I have if the element to be inserted is less than or equal to the first element, of the list, which could be accessed as list of 0 or list of CTR. So initial value of CTR is 0. So list of 0 means you're referring to the first element. So if the condition is true, either the first element is equal to 10 or less than 10, the appropriate position will be 0. So in this case, why don't you assign 0 to the value of position, right? Now the next up is, I now need to run a loop. I need this loop in order to check whether this 35 is in between 0 and 1, if not 1 and 2, if not 2 and 3, if not 3 and 4. If this is the case also, then it has to be the last position, alright? So the condition is going to be like this. If the ELE is greater than this and less than this, greater or equal to this, or and you have to use the AND operator. Both the conditions need to be true. Okay, so you have to run the loop while as long as you have the CTR value is less than the U. Okay, this is the U will be the final index, and then CTR will start from 0. I have a reason why I have not have this equal to sign. This will raise a runtime error, which I'll get on a little later. So as long as this condition is true, I now write all important condition, which is if the element to be inserted is greater or equal to list of CTR. Okay, so the value of CTR will be 0. So you're clearly referring to whether the element to be searched is greater or equal to the first element. At the same time, you need to ensure whether it's less or equal to 1. So this one could be retrieved by adding 1 to CTR. So CTR value is 0, and then if you add 1 to CTR, you're clearly referring to the next one. So this is very important part of the program, and both the conditions need to be true. And then if ELE is less than or equal to list of CTR plus 1, okay, you have the colon. So both the condition needs to be true. If both the conditions are true, then the value of position will be CTR plus 1. Let's say if I want to insert 15, don't worry, we'll run the program all over again. So let's say if the value of this is 15, EL is 15, so this condition will be true. Okay, EL 15 is greater or equal to 10, 15 is less than or equal to 20. So both the conditions are true. The position will not be 0. The position will not be 0. It has to be 0 plus 1 is 1. So the 15 should be here. So this is the reason why I have to add 1 to CTR. Okay, so if the conditions are true, the appropriate position will always be CTR plus 1. So if the conditions are true, then what you do is you just leave the loop, right? And then I'll just have the break statement. Okay, I'm done with the loop. And then next, the step will be, if the condition is false, then what I have to do is I need to increase the value of CTR. Okay, let's say if both the conditions are false, okay, and then I now need to increment the value of CTR. So this is the problem with the writing program on the whiteboard. So it needs to be here. Okay, so if both the conditions are the true or false, then it comes here. The value of counter will be incremented by 1, and then the loop resumes. Okay, so this will go on until you have managed to find the value, and then otherwise keep the indentation properly. and then I'll have the else statement. Okay, I'll have the else statement. When will this else be executed is if the while loop completes all the cycles. If it completes all the cycles, let's say you have the value of CTR as 0, you have the value of CTR as 0, and then the value of U is length of list 1, 2, 3, 4, 5, 5 minus 1 is 4. Okay, so when the value of CTR becomes 4, the condition becomes false, which means the while loop has completed all the cycles. When will while loop complete all the cycles is if this condition has never been true. If the conditions have never been true, which means I can safely say that the element, is not to be inserted within the list. Okay, the element to be inserted is not within the list. It will be after, or it will be at the end of the list. So in this case, what you should do is, so if the while loop completes all the cycles, then the value of position will be the final value of CTR. May I know the final value of CTR? The final value of CTR will be 4. When the CTR value becomes 4, 4 is less than 4, the condition becomes false. And then this is how you leave the while loop. So the value of CTR is 4. So you have to add 1 to the value of CTR. The CTR being 4, 4 plus 1 is 5. So if the new element is to be inserted at the end of the list, it cannot be 4, it will be 5. 0, 1, 2, 3, 4, 5. Right? So let's try to understand this program. Let's say if I have 60 here, okay, let's say I have 60 here. We'll just run the program real quick. Okay, value of CTR starts from 0. Okay, this will go on. The condition will never ever be true. The 60 is, even though if it's less than this, but it's not greater than this. If it's greater than this, it's not less than this. Okay, if it's greater than this, but it's not less than this will go on and on. The condition will never ever be true. Okay, so finally the value of CTR will reach the value of 4. Okay, and then this else statement will be executed. Now the while loop has successfully completed all the cycles. The value of CTR being 4, 4 plus 1 becomes 5, and 5 becomes the appropriate position where the value of 60 is supposed to be inserted. Okay, and then finally, the whole thing will be little this side. Okay, make sure that this block, you have the else here, sorry. After this, you have the else block. Okay, so this as a whole will be the body of this else, and this will be the body of this if. Okay, so and then finally, once you're done with the function, you have to return the value of position. All right. So this is going to be the first part of your program, finding the appropriate position of the element to be inserted. Okay. Now the next will be, the shift function def. Hopefully I'll be able to finish till this point. Def, and then another function by the name of shift. And this, now we'll keep, the example to 35, all right? We'll keep the example to 35. So this part of the program, when it's done with the execution, it will return the position of 0, 1, 2, 3. This will have the position of 3. Okay? The value of position will be 3. And now, the next part of the program will be shift. You again have the list and then followed by the position, which will be POS. I'll be writing the main part of the program a little later. Okay. Now the next up is you have the shift function. Now the first things first, I need to expand the list by one more element. So I hope you do remember the function which is used to add one more element to the list, and that's going to be append. So list dot append, and then I'll have a special value called none, okay? So you have this. So this none is a special value of a data type called none type, which is actually used to refer to a null value or a value which does not exist. It refers to a null value or it refers to a value which does not exist. So you now have, with this particular statement, we now have an additional slot with the value of none. Okay? And then, now once I'm finished with this, I would like to have the, I think I will be needing this. The next step will be, I'll get the size equals len of list and then minus 1. Okay, I now got the size. Now the logic of the program is going to be like this. I now need to shift this 50 to this. Okay, I now need to shift this 50 to this particular location, 40 to this particular location, right? So which means I now have the case of a while loop. I need to keep running the loop. So I'll have the while statement. While size is greater than position, okay? The value of size, you need to be very careful. The value of size, length of list, I'm now talking about the new list, okay? After adding the new element, the length of list will be 1, 2, 3, 4, 5, 6. Is it? 6 minus 1 is 5. So the value of size is 5. The value of position is 3. Remember, the value of position is 3. I'll just write here, the value of position is 3. So as long as this condition is true, I need to keep on with transferring the value from the index number 4 to 5 and 3 to 4. Okay, so the condition is true, and then how do I copy from here to here is, how do you refer to this? How do you refer to the value of size is, the value of size is 5, right? So I'll have list of size, okay, 0, 1, 2, 3, 4, 5, right? List of size is equal to list of size minus 1. Okay, the value of size is 5. The value of size is 5. 5 minus 1 is 4, which means the list of 4. The list of 4 is 50. List, the value of size is 5. 5 minus 1 is 4. List of 4 is pointing to the 50. 50 will be copied to the value of size. The value of size is 5. Okay, so the list of 5 is referring to the null value or the none value. So in a way, list of 4 is 50. 50 is being copied onto this. So you now have 50 here. Okay, and then I need to reduce or decrement the value of size by 1. This is the shorthand expression. So the value of size will now be 4. The value of size will now be 4. 4 is greater or greater than 3. The condition is true. Since the value of size is 4, 4 minus 1 is 3. List of 3 means you're pointing to the 40. So the 40 as a value of list 3 will be assigned to the size. The value of size is 4. Is it? Okay, go real slow. So list of 3 will be copied onto list of 4. List of 3, which is 40, will be copied onto list of 4. So which means you will now have 40 here. Alright, you now have 40 here. And then the size will be decremented further. It will be, the new value of size will be 3. This is where the loop should stop. 3 is greater than 3, the condition becomes false. And this is the exact time where you should leave the loop, because you're done with transferring all the values from 50 to none and 40 to 50. And now the final task is to replace this value with the new element that is to be inserted. Okay, so this is going to be the second important part of the program. All right, and then now let's complete the program. The first part, second part, you now have the main part of the program. So we'll write the main part of the program like this. List is equal to, please be careful, this as a whole will be indented, towards the inner side of the else block. Otherwise, you will mess up when you run the program. Okay, if this is true, else then you have the whole while block, and then finally you have the return position. So initially the value of list, sorry, it's getting a little messy, it's a little different. This is the main part of the program, or just write here, the main part of the program. Okay, so you have the list content. L is equal to, you have 10, 20, 30, 40, and then you have one more, that's right, you have the 50. All right, and then the element to be searched is, the element to be inserted is 35. And then we'll get the position. Position is equal to, let's call the first function, the name of the first function is find position, and then set both arguments. The first one is L, the second one is E. This whole list is represented by L, and the element to be inserted is 35. So these two variables will catch up the list elements as well as the element to be inserted. So once we get the position, what do we do now? We now need to start shifting the elements to make room for the new element. So let's call the function straight away shift, but I need to send L. Now this time, E is of no use, because all I want to do is just shift the elements, right? But in order to shift the elements, I need to send the value of position. That's really important, right? Till the value of position, I need to carry on with the shifting, right? So go on till this condition is false. So you have the position. Okay, I've already explained the logic. So L will be assigned to list, position will be assigned to P or S. So, and then finally, so once you make room, you now need to replace this particular element with the new element. How do you access to this element? The index of this element is represented by the variable of P or S, or in this case, position, right? You call the function, and then the post value will be returned and be assigned to position, right? So you will have the appropriate position value in position variable. Okay, so this is how you access that specific element. So it's going to be L and then position. Okay, L position is equal to the value of E. So this is how you replace this, and finally when you print the value of L, you are supposed to get the final output as 10, 20, 30, 35, 40, and then you have the 50, right? So let's take another example. Let's say I want to insert the value of 60. Okay, we'll try to do this real quick. I want to insert a value of, originally, this is 40 and this is 50. I would like to insert 60, alright? So this will be 60. Okay, let's do this real quick. This is 60. Okay, L will be sent to list. E, the value of E is 60. Length of list minus 1. Length of list minus 1. 1, 2, 3, 4, 5. 5 minus 1 is 4. Okay, so the value of U is 4. Initially, the value of 60 is not less than the first element. 60 is not less than 10. So this condition will be false. It gets on to the else part. And then the value of counter initially is 0. Okay, it is 0. So ELE being 60. 60 is greater than the first element. Now this condition is false. It's true. 60 is greater than the 10. But is it less than 20? No. So again the loop continues. Okay, it reaches here. This condition is false. It reaches here. The counter will be changed to 1. Again, 60 will not be in between this. Nor it will lie between this, okay? So when the final value of 60 is, even though it's greater than 40, but it's not less than 50. So finally, when the value of CTR becomes 4, okay? Finally, when the value of CTR becomes 4, the condition becomes false. So the loop has completed all the cycles. The value of position will be 4 plus 1. 4 plus 1 is 5. So 5 is the appropriate position where the 60 has to be inserted. So if you go by the syntax, index, 0, 1, 2, 3, 4, 5. So this is where it should be. But as of now, we don't have the new slot for the list. Okay? So this is the reason why we need this. So the final answer or position will be 5. Is it 5? And then you will now have the value of position as 5. I sent 5 as position value to the shift function. Okay, and right here the value of position will be 5. Alright, so let's start append. It will add a new element with a value of none, and then which will ensure that you have one additional slot at the end, thereby which I'm going to get something like this, and the index of this will be 5. And then size of length of list minus 1. This time I have 1, 2, 3, 4, 5, 6. 6 minus 1 is 5. 6 minus 1 is 5. So you will have the value of size as 5. Okay? You'll have the value of size as 5. Right. And then the value of position is also 5. So look at this. So since the new value is to be inserted at the end of the list, will there be any shifting that's going to take place? No. Okay, we don't have to disturb the order of the numbers, because the element to be inserted has to go to the last slot. Hence, the very condition will become false. Okay, so at the very start, the condition becomes false. The whole loop will not execute at all, and thereby which no shifting will take place. And then you leave the function and then come back, and then the L of position, the value of position, remember it's 5. So L of 5 means you're referring to this. So this is how you assign 60 to the last slot. Okay. So this is how the entire program works. But remember, this program is using the traditional approach. But I'll be showing you the Python method of inserting, using some function. That's going to be real easy. Okay, so now the next step or the next method is going to be through the means of Python programming language. In fact, this is again nothing but a part of Python programming language. But in Python, we have new functions, new built-in function with which you could do the insertion with ease. So I'll just write here Pythonic way. Okay, so you'll have to import a module called bisect. Bisect means to divide into two equal halves. Okay, this is nothing but a module. We have learned a bit of module in the earlier video lessons. Module is nothing but a package of software routines, where you will see a lot of functions. So once you import the module, you'll be able to use the function. It's like a toolbox. So you say you have some mending work or construction work. First, you need to get the whole toolbox. You need to have it. So that's like a module. And then you pick up the spanner to tighten the screw. That's like using function, as one of the functions which are defined in the bisect module. So you need to get the whole module into the RAM. Only then you'll be able to use the functions which are defined in the bisect module. Okay, and then you now have the list like this. Say list is equal to, let's say, 10, 20, 30, 40, and then you have 50. And then the element to be inserted is, let's say, 35. Okay, and then POS equals, you have the bisect module followed by bisect function. This is the module and this is the function. It's something similar to math.pow, math.pow, right? So this is the module and this is the function, right? And then you have two arguments. You'll have the list and then you have the ELE. So this bisect function, this is the bisect module and this is a bisect function. So this function will look in for the index of ELE in the list. I repeat, this bisect function will look out for the index value or the position of the ELE in the list. Now the question is, how does it function? Okay, so behind the scene you have the function definition for this, which will be something similar to the logic, which we have just understood now. Okay, just a little back. So, but here in Python, you have this the function via which the actual task is being carried out automatically. But technically, this is nothing but a function call, just like how we called find position, how we call shift. This is nothing but a function call. This call will take us to a function definition which is defined in the bisect module. So as a result of which we are going to get the index value or the appropriate position or the deserving position of the ELE in the list. So 35 should be between 30 and 40. So 0, 1, 2, 3. So the 3 value will be returned and will be assigned to POS. So perhaps you can write ELE found at index of POS. Okay, since 0, 1, 2, 3, 3 will be returned, the value of EL is 35. 35 is found at index of 3. 0, 1, 2, 3. Okay, you have 0, 1, 2, 3, and then you have 4. And then in order to carry out the shifting process and the final step of inserting the new element at the appropriate position, you have another function by the name of, you have again the bisect module, and then you have insert. Be careful. As per the question, it looks or it sounds as if this is common wise, this has to be like insert, but be careful, this is not insert, it's insert. So what happens here is this ELE value will be inserted at the appropriate position of the list with the help of insert. So again, approximately, roughly, you could imagine that the logic behind insert function will something be like the shift function and the final assignment of the new element at its appropriate position. All right. So, and then finally, when you print the status of the list, okay, you will get the answer as the output will be 10, 20, 30, 35, 40, and then you will have 50. So the key things to be noted is this is the module, and this is one of the functions which will return the index of the element. Index of the element or the appropriate position of the element. In fact, this is better. Appropriate position of the element to be inserted, the bisect, and then insert will eventually insert the new element at its appropriate position, and then you could check the final status of the list. It will be something like 10, 20, 30, 35, 40, and 50. So this is how you carry out the insertion task in a list using the traditional approach, and then you have the Pythonic approach, all right, or through the means of Python by using the functions which are new in the Python programming language. Now, when I say traditional, I'm still using Python programming language, okay, but the difference is I'm using the new functions which are developed in the Python programming language. But it's a good idea to be able to know the logic of this. Okay, otherwise this is something like what you see is what you get, right? So this is the reason why at any cost you need to know how the program works behind the scene, and then you'll be able to relate better. Now let's move on to the next program. The final program for today is going to be the deletion, all right? So I'll just put it on this. Deletion will be far more simpler than the insertion. Just get rid of this real quick. Okay, I'll be using the same old list. So in the deletion, what happens is, I need to know the position of the element to be deleted. See, I'm running through the algorithm. Okay, first step is I need to know the position, the element to be deleted. Let's say I would like to delete 30, from the list. So first things first, I need to know the position. Now, once I know the position, let's say this, what you do is position plus 1 will be assigned to position. Okay, 40 will replace the value of 30, 50 will replace the value of 40, and then finally get rid of this. Okay, I hope you have understood the logic of the program. First things first, I need to get the position of the element to be deleted, and then carry on with the shifting of elements towards the left, and then finally we need to get rid of the last. 40 will be copied here, 50 will be copied here, and this has to be off the list. Okay, so this will be the logic. Now, in order to find the position of a given element, it's very different from the earlier program of inserting an element into the list. Now this time we need to know the exact position. Okay, so we could either use linear search or binary search. So we'll use the binary search to find the index of the element to be deleted. Alright, so this will be like deletion. Okay, this will be the deletion. Okay, let's first start with the function definition, def, and then you'll have the name of the function as binary search, and then you'll have two arguments, list, and then you have the ELE, all right? So this element is to be deleted from the list. And then let's quickly have the binary search program. We have done briefing already, so let's not waste time on that. I need two variables, if you remember. Low is equal to 0, high is equal to length of list minus 1, okay? And then I run a loop while low is less than or equal to high, okay? I need to move on. I need to get on with the middle value. Remember, you have the whole list. Get on with the middle value and check if the middle element is equal to the element that is to be searched. If it's not equal, I check whether it lies in the later half or the former half. If it's greater than the middle element, then it means it's in the later half. Then I change the low value to the mid plus 1. If the element is less than the middle element, then it means the element is in the former half. So I get the high value to mid minus 1. So this will go on and on until the program manages to pinpoint the index value. So just move on with this. Mid equals, and then you have the int, okay, mid, oops, sorry, you have the low plus high, and then you have divided by 2. Okay, so 0 plus 1, 2, 3, 4, 5. 5 minus 1 is 4. 0 plus 1. 0 plus 1 is, this is what? High is how much? 1, 2, 3, 4, 5. 5 minus 1 is 4. 0 plus 4 is 4. 4 divided by 2 is 2. So you are pointing at the mid value of 2. So you are pointing at the middle value. And then just run this check. If element to be searched is equal to list of mid. Okay, if through a nice coincidence, if the element to be searched, is found at the middle position, good luck to us. And then I just return the value of mid. Else, LF, ELE is greater than list of mid. Okay, if it's greater than the middle element, then I need to get the low value to this. I need to narrow down the list. So this is going to be low is equal to mid plus 1. Otherwise, I'll not explain much. High is equal to mid minus 1. Okay, and then finally you have to return the value of mid, right? So with this, the program will manage to search and retrieve or return the index value of the element to be searched in the list. Now the next step is, once I manage to find the value of mid, so just right here, running out of the ink. Okay, now the next important function will be diff, and then you'll have the shift. So it'll be receiving two arguments. The first one is a list, and then you will have the position, right? Okay, and then you will have the value of size is equal to the length of list minus 1. Okay, now the next step will be the length of list is how much? It's 1, 2, 3, 4, 5. So 5 minus 1 is the value of size is 4. So 0, 1, 2, 3, 4. And then the value of, this is the value of position, is it? Right? Say if you look out for the element value of 30, the answer will be 2. The answer will be 2, right? So the index value of 30 is 2, right? So I just have here 2, and then the value of size is equal to 4. Now think properly. So what I do here is, I copy the value of position plus 1 to position. Is it? I need to copy this 40 to 30. 30 should be replaced by 40. 40 should be replaced by 50. So your focus should be on the variable of the position or the pos. So run the loop. You have to run the loop while, okay, position is less than the size. Okay, you need to think properly over the logic and then try to narrow down into the loop condition, right? So the value of position is how much? It's 2, and then you have the value of size as how much? The value of size as 4. Okay, 2, right? Okay, so now the condition is going to be like this. You have the list, okay? POS should be replaced by list of position plus 1. And then you have to increment, the value of position by 1. Okay, let's just check out. The value of position is how much? It is 2, and then position plus 1 is 3. We'll go real slow. List of 3 is pointing to 40. List of 3 is pointing to 40. List of 2 is pointing to 30. So which means 40 will be copied onto, or in other words, 40 will replace the value of 30. Okay? So at the end of this, the first loop, this will be the status. And then the new value of position will be 2 plus 1, it will be 3. So you will have the new value of position as 3. 3 is less than 4, the condition is again true. And then you have 3 plus 1 is, okay, new value of position being 3, 3 plus 1 is 4. And then you have the original position value as 3. So list of 4 will be copied onto list of 3. List of 4 is pointing to 50 and list of 3 is pointing to the 40. So 50 will replace the 40, which means we will now have 50 over here, right? And then the value of position becomes 4. The condition becomes false. Okay, so this is how you leave the loop, and then finally, just complete the program real quick. This is L. This is the main part of the program, and then L 10, 20, 30, 40, and then you have 50, right? And then E equal. I would like to delete 30. 30 is the value that is to be deleted from the list, and then let's call the function. The name of the function is position is equal to, you have the B search and then send both arguments of L and E, and then from here, once I finish with the execution of this, I'll get the value of 30 decided as, I've just made some modification. 30 was here, remember? So you'll get the value of position as 2, and then call the function of shift, and then send that big L, and then send the value of POS. Okay, so once this function has been executed, the status will be like this: 10, 20, 40, 50, and 50. So I need to get rid of this. Is it? So L, you can use the slicing of the list. I hope you remember, slicing of list as covered in class 11 syllabus. So why don't you slice the list like this? Colon, you're supposed to have the colon to separate the starting value and then the end value, right? -1. So whenever you use the negative value as index, the counting should start backward. Remember? Okay, if you want to consider counting of index forward, then it has to start forward, but from 0. If you want to use the negative, it starts backward, -1, -2. So this means I want the new list to be starting from the first element till -1. So the -1 points to this. So this is -1, -2. This will go on and on. But this particular value will not be considered. -1 will not be considered. So this slicing means I want to start from the first till -1, but the -1 will not be included. So it will move on till -2. So which means the new, if you print the new value of list, you will get 10, 20, 40, and then you will have 50. So this will be sliced off using colon with a -1. So this -1 as index, is specified, but it is not considered. So -1 is thus excluded from the list. So this is how you carry on with the deletion of the element from the list. Now the next step is how do you do it using the Pythonic way, or the functions which are used in the Python programming language. This is straightforward. You need to pause the screen and copy the program. Don't worry, I'll be giving you the notes. So we can make it real easy. Instead of this, instead of slicing of list, or to be precise, I can get rid of this. I can get rid of this, and then I can use a Python keyword called del, which is used to delete an element from the list, and automatically, the shifting will also take place. So with the help of del keyword, it will not only delete the element of the list, but the shifting, upward of the successive or the subsequent elements will also take place automatically with the help of del. The name of the list is L, and then the index is nothing but E. So what happens here is 30. The value of E is 30, right? So L of 30. L of 30 means you are pointing to. L of 30 means, right, L of list is L, and then this is, I'm so sorry, you have POS. The position, the value of position is 2. So this del keyword will delete the element which is located at the index of position in the list. So the value of POS is 2. So this del keyword will delete the element of L of 2. L of 2 means you're pointing to, so originally, this is 30, this is 40, and then you have 50, right? So the value of position is 2. L of 2 means you're referring to 0, 1 to 30, and the 30 will be deleted. So I got it a little wrong. I should have written POS. So del keyword will delete the element which is residing at index of POS. So which means if I use this, do I need this? I don't need this. I can get rid of this. So just imagine how, with the usage of Python, the newer functions, you can simplify that big program into a very small program. But having said this, it's important to know the traditional approach also. And then the whole thing, this whole thing could be done away. So instead of this, I can use a function called index. Again, this del, and then the function like index, extend, append. Those were the functions which we have learned already in class 11, right? So here, what I can do is POS equals, I can use, L dot index of, and then you have E, right? Need to be careful because there are just too many functions. So L is the list that contains the original elements like 10, 20, 30, 40, and 50. Alright? To which I use or I apply a function called index. So this function will return the index or the position of E in the list of L. I repeat, this particular function will find the index position of E in the list. Okay, so this is a 30, this is 30, and then you have, the 30 will be scanned in the list, and then 30 is found. It is found at index of 0, 1, 2, and the value of 2 will be returned to position. Okay, and then using del keyword, you can delete the function. So that big program of deletion could be summarized in a matter of just how many statements? 1, 2, 3, 4, 5, right? But you are taking the help of the predefined function like the index and the keyword like del. Okay, so with this is actually a substitute for the binary search function. It's not the exact substitute, just roughly, if I tell you, the whole thing could be replaced by index, because this is all about searching the index, remember? And then shifting is all about shifting the elements, and then finally, having the last element of the list, removed. So those two operations could be performed by del keyword, right? So the whole deletion process could be substituted by the index and then this. So this is how you write the program for the deletion, okay, using the traditional approach and the Pythonic approach. So with this, I would like to end the today's session for the data structures. You can, in fact, it's a good idea to be watching the video again and again, especially those parts with which you are not too happy with the explanation or understanding. Try to watch it again, and then once you are completely thorough with the understanding of the program, and then you must, I know it's very difficult for everyone to be possessing the laptops, but if you could somehow adjust, for a computer, the practice is a must. Okay, so with this, I would like to draw my lesson to an end, and then I'll see you next week, which will be a continuation of the data structures. Until then, take care and thank you very much.